Hello there, welcome to another exciting topic on physics with Chris. In today's lesson, we are still on friction. So we want to look at this question on friction as example. So let's look at this question. A body of mass 40 kg is lying in an inclined plane of slope 30 degrees and it's on the point of sliding down. What force parallel to the plane will cause the block to begin to move up the plane? A body of mass 40 kg is lying on an inclined plane. Of slope 30 degrees and it's on the point of sliding down. What force parallel to the plane will cause the block to begin to move up the plane? Let's look at how the diagram looks like. You have an inclined plane of slope 30 degrees. Then you have a block that is lying on it. Now, this block will be acted upon by four forces. You have the force parallel to the plane that want to drag it up. Then you also have the weight of the body. Then you have friction also. And recall that the weight of the body that will act downward, since it's on a sloping ground, will be mg sin theta. And the frictional force F is equal to mu r. So these two forces will be acting to drag the body downward, while this one want to drag it upward. So you have force dragging it upward, and these two forces dragging it downward. Frictional force F and the mass of the body mg sin theta. Then you recall that our mu, coefficient of friction, this mu, coefficient of friction, can be obtained by using tan theta. So you have mu is equal to tan 30 degrees. So that our mu will be tan 30 is 0.5774. Then you recall that our R, normal reaction, is mg cos theta. R is equal to mg cos theta, which is the force that will act parallel to the plane in this direction. Mg cos theta, which should be equal to the normal reaction, R, acting upward. So in this case, our normal reaction R is mg cos theta. Then if I substitute my value here now, I will have R, mass of the body is 40 kg. Our acceleration to gravity G is 10 meters per square seconds. Then cos 30. So my R will be equal to 40 times 10 cos 30. And that will give me 346.4 Newton. Then my frictional force F is equal to mu R. So that will be F. My mu is 0.5774. Then my R is 346.4 times 0.5774. So my force is 200 Newton. So my frictional force, this frictional force here, let me say Fr, frictional force Fr is 200. And the weight of the body that is acting downward also, that is mg sin theta. You have mg sin theta. Then you have W is equal to 40 times 10 sin 30. So W is equal to 400, 40 times 10 sin 30. So that will give me 200 Newton also. Then if I add together now, the frictional force F that is starting like this now be equal to F is equal to F is equal to W plus FR. Then F will be equal to 200 plus 200. That's 400 Newton. So the force that will drag this body upward is 200 Newton.